what I'm going to do is I have a couple of slides before I actually go into the code that will like a little high level slide that will help to kind of explain what you're going to be seeing as I take you through the code. So this is my first slide, and what we're going to be focusing on is reservations under hotel management. And what we're going to be doing is sending a command called reserve room. And this is just a high level flow. It's going to be reserve room. It's going to resolve to a reserve room handler. The domain will then emit an event called room reserved, at which point something will react to that event, a subscriber, and we will have an event handler called room reserved handler, and that will be responsible to work with a repository to update the read model. Okay, and that's pretty much it. The way that the solution has been structured when I open up the actual solution is this is known as layered architecture. And it's broken up between application layer, domain model layer, and infrastructure layer. So you can see in the application layer, you have the API, your domain model layer is your domain, and your infrastructure is your infrastructure layer. And because when you're dealing with a lot of these patterns, like you're gonna, like domain-driven design, aggregates, handlers, commands, events, etc. It's where do you put all this? Right? You know, there's been a lot of attempts. I'm even guilty of it in the past when I've tried to attempt at building systems like this to figure out where the hell do I put, you know, an event, you know, like the object itself. Where do I put my handlers? So what I've been doing is I follow this until someone shows me a better approach. Right? Solution. The triggers that we're going to be focused on are in red. It's going to be an HTTP trigger and a topic trigger. Okay, well, there's going to be a subscriber, and it's going to be a service bus trigger that will create an instance of a function and react to the event. And if someone does a post, the HTTP trigger will create an instance of the function. And actually, we go from there and handle the command. And this is the basics of this CQRS implementation. Now, there are many out there. There's a lot, some good, some bad. And it's evolved. Even at AdaptTech, we have much more efficient ways of doing things, but this is kind of like the traditional approach. So I'm just going to, because these are some of the terms that I'm going to be using as I'm moving through the code. So a command is an action and an intent. It's do this, okay? Your dispatchers, we're going to be using dispatchers in this implementation. They're going to resolve a command, an event, or a query to a corresponding handler. A command handler itself is an orchestrator. And it's basically what should be done with that command, right? And there's actually a couple of steps in your command handler for that. Your events are statements of facts. They're the outcome of a state transition. So a command is do this. A transition occurs, right? Room has now been reserved. And then you have that outcome, which is your statement of fact. So this is one of the reasons why I'm not a big fan of CRUD anymore. We were talking about this the other day, because with CRUD-based systems, you lose that statement of fact. A change occurs, and guess what? There's nothing there that says that change occurs. All you have is a record in a relational database that has the most current state, and that's it. That's all you got, unless you go and add additional logging to do that. But this is implicit. It's baked into the design. That's why I'm a big fan of this. Now we have the event publisher. In our case, in this implementation is the service bus client publishing to a topic. I've wrapped it, right? So I can swap it out depending on which vendor I'm working with. The event subscriber in this implementation is the service bus trigger function, subscribing to a topic with a filter on a specific event. That way, I'm not triggering functions for events that I don't care about. on a topic. And then I have my event handler, which is the orchestrator on what should be done with an event, okay? And you have your read model. That's your persistent data in the shape of a UX or a report. Your query, it's your search criteria, and your query handler, which is an orchestrator on what should be done with the query, okay? So now what I'm going to do is take you guys into the code. So this is hotel management, and this is just reservation. There's all kinds of other subdomains in hotel management, but I'm just focusing on this for this presentation. I'm going to open up Reservation API. I'm going to open up the function. You can see that I have a reservation functions class, and in here, I have a function called reserve room, and it's going to accept a post. And what it's going to do is take that request body, and it's going to deserialize it to a command. Okay? And then what it's going to do is it's going to call this command dispatcher. And all this dispatcher is responsible for doing is resolving the command to a command handler. So, all right, sure. Let's see here, so guys. Better? Oh, it's a bit much. No, because I got my own thing going on, dude. I got to do it my way. Sorry, buddy. I don't want anybody wrecking the flow here. Oh, mic's on, sorry.
You guys are getting a listen and dealing with Tim 101.
Well, sorry, guys. I think because I actually want you to see a bit of the code. If it's too big, then it's going to be cut up. Are you telling me you can't read that? Okay. All right. All right. So anyway, all right. It's cut off a bit. Fine. I'll live. Rob, zip it. Okay. So now what I'm going to do is show you a bit of the command dispatcher. And all it's going to do is this is my wrapper around Microsoft's dependency injection container. It's my dependency resolver. And all this is going to do is resolve the command to a handler and then call handle. And in this case, what I said here is, you should be checking to see if the handler is not found. You can also do retry attempts in here, etc., whatever. But you're probably wondering, well, where's the wiring that occurs with this, how it's resolving it? So with Azure Functions now, they support the baked-in Microsoft dependency injection. And you can see here, I've actually wired it up inside the startup CS. And I have the command handler, reserve room, equal reserve room command handler, okay? So that's kind of how you wire it up. And then you use the dispatcher. Some people use command bus. They use all these different terms, but I wanted to keep it just across the board dispatcher for now, for the event, the query, and the command. So now what I'm going to do is I'm going to go into the actual handle. Now that we know that it's resolved and we're calling handle, we're going to go into the actual reserve room command handler. And you can see in here, it's very succinct. It's only a couple of steps. It's an orchestrator. It does not and should not contain business logic. And at my previous company, a lot of people, when they were learning CQRS, they were actually putting business logic into these. And I could only be so many places at so many times to do code reviews, etc. Which is why I'm a big fan now at AdaptTech. We use a generic command handler because you can see there's really 4 basic steps and it's always on that one entity, aggregate, entity, whatever term you want to use. So you can see that we're going to use a factory to return a room. We're then going to call the actual reserve on that room, and we're going to pass in the data. And then what's going to happen is it's going to raise an event right here. Nothing fancy, right? And then what's going to happen is once that event is raised, we're going to then pass that on to a repository that's responsible for persisting to the event store. Once that's done, we're going to take those events and we're going to publish them out onto the bus. And that's very important because this is where a lot of systems fail, because what they tend to do, and especially with Kafka, we call it MESS, Monolithic Event Source System, is that what they tend to do is they publish out onto the bus, and then they slap on a subscriber. And then what they do is they go update their event store. And you can't guarantee order in that scenario. So you always want to persist to your event store before you do anything or put anything onto it. Okay? But as you can see, the command handler itself has very few lines of code. It's doing a couple of things. Like I said, getting your entity, doing something on it, persisting it, and then publishing. And that is all. And that is your right side. It's done at that point. Okay. So if I were to go, I'm just going to show you something quickly. And the publishers under my infrastructure, I've wrapped the service bus. So you can see, so for some of you that are new to using Microsoft technology, there's a service bus client. And you can see I have a topic client. And this is how I would push it out onto the bus, okay? Service bus. So now what I'm gonna do is I'm gonna actually put this into debug mode for you all. And I'm going to actually use Postman and send a command through. And then it's going to put onto the bus, onto the topic, reservations events topic, the actual event that the room was reserved. And I'm going to show you that. Yeah. Now here's my post. Send it off, fire it off. And I got my 200 back. Okay. So now I know that this has been executed and it was successful. So now what I'm going to do is I'm going to use a tool, and it's called Service Bus Explorer. So what this tool does is gives you visibility into the actual Microsoft Service Bus. And I can actually see the event in my topic. So if you look at reservation events topic, and under the subscriptions, I'm going to refresh, and you're going to see there's my event. Shows up, bam, right there. And then I'm going to actually just peek into it to show you guys what it looks like. So there it is inside here, and it's waiting to be consumed by my subscriber. And you can see I've tagged it with the content type of room reserve. And that allows me to, if I need to, for whatever reason, because I'm using a filter, I can actually say, hey, this content type, if it equals room reserved, that's the event I want to filter on. So I can be very granular, because I believe that functions, it should all be one-to-one, right? One command, one function. Same thing with a subscriber. If you have a subscriber function, one function should be equal to one event. So that's pretty much it. That's waiting to be consumed. So now what I'm going to do is I'm going to take you guys through the persisting to the read model. So we're going to actually, I'm going to show you an event handler, working with a repository, and then updating the read model. And what it's going to do is I'm going to show you the service bus trigger on a function that does that. So now what I'm going to do is go down to my subscribers here. And I have my function. And in this case, it's the same thing as the command dispatcher. I have an event dispatcher. And I could take you guys through it. You can see here, it's doing the same thing as what the command dispatcher did. And the only difference is that it's going to resolve an event to an event handler. And once again, if you go under the startup of the subscriber, you'll see that I wired up that event handler to that event right here. That's my wiring right there. So that's how it's going to be able to figure out how it got it. So now if I go into the function itself, there it is. So I have this, sorry, that's wrong because I was doing something else. But anyway, this is the reservations event subscriber function. And inside here, I have an on room reserved event function. And what it is it uses a service bus trigger. And this is the annotation you'd use for that. Service bus trigger There's my topic. There's my subscriber. This is all in a config file somewhere that defines what it is. In my case, I'm explicit with my name, my parameters here, and it's called room reserved event subscription name. So we already know what that is. It's the name of the subscription that's waiting for this to react to the message that's stored on the service bus. So we know that the event came in. So I'm going to take this event message that came off the bus. I'm going to deserialize it to an event, pass it on to the dispatcher, and then the dispatcher will resolve it to the handler. And then if you go into the handler, very simple. It's using a read model repository. And in this case, it's a generic repository against table storage for the sake of this presentation. And this is it. It's literally going to take the information from the event, set up the entity, and pass that on to the actual read model repository. And that is all. So that's how you would react to an event, resolve the event handler, then persist to the read model.
If you think back to what Adam was saying earlier, this is the whole crux of the system. We're taking a little bit of information, changing it, we're making sure it persists. And it shows up that way in code as well.
Right. So now what I'm going to do is I'm going to actually put this into debug mode, which is great. You can actually run your functions locally and you can actually debug them locally. So I'm going to put this into debug mode and I'm going to run it. And then what it's going to do is it's going to react to the event, find the event handler, then work with the repository, and then update the table storage. And you can see that it's been executed. Done. So now, I'm going to use a tool called Storage Explorer. So this gives you visibility into the storage accounts in Azure. And table storage is in storage accounts. So in this case, I have one called Hotel Management Storage, and I have a reservation read model. Let me just refresh this. And there it is. There's my read model that's been updated with that record. Right there. So now that I have that record in the read model, now there's a UX experience. There's some, someone's at a hotel and someone calls up and said, I've reserved this room or whatever. So now there's this read side to CQRS. So what I've just taken you guys through is I've taken you through the write side. I've taken you through persisting to the read model. And now I'm actually taking you into the read side. So we're going to go back to the API, Reservations API. And under functions again, you're going to see that I've created another one. It's called Get Reservation by ID, right? And what it's going to do is it's an HTTP trigger marked as a accepting a GET request. It's going to get a reservation ID, and then it's going to build a query. And then that query is going to get passed on to a query dispatcher. And just like with the event dispatcher and the command dispatcher, what do you think this one's going to do? It's going to resolve the query to a query handler. So now we're going to go into the actual query handler. And in here you can see it's using the same repository. And what it's going to do is it's going to accept that query, and it's going to take that reservation ID, work against the repository, and return a result. And then I'm just taking that result and converting it to a DTO to send back to the client, or which is a data transfer object to send back. Because I don't want to take an entity or a model that's a back-end data model, and I do not want to persist that to the front end, or sorry, transfer that to the front end. I want to have some type of data transfer object for backwards compatibility, etc. So that's pretty much it for the entire CQRS pattern. The write side, persisting to the read model, and the read side. So you can see it's pretty simple, right? There's not a lot of code there, which is why you don't need a framework, right? So that's one of the biggest problems that we face in this industry is that people, they get caught up in all the buzzwords, and then they go out and get all these frameworks to do this stuff. But if you truly understand the pattern, you find that it's really boils down to some interfaces. And you don't really need to go out and introduce a new framework, which is actually introducing accidental complexity into your domain. Because the only type of complexity you really want to focus on is the complexity that's inherent in the actual domain or the problem that you're solving. There's going to be complexity that comes in just on the problem itself. You don't want to bring in all these extra frameworks. So just be conscious of that. So that's it for like the actual code walkthrough. But what I want to say is, why do we love these patterns? Adam, myself, a lot of people here. And the reason is it leads to boilerplate cookie cutter code. Okay. So it's for rapid application development. You can take the event model. We've actually discussed this, taking the event model, and you look at the infrastructure as code that we talked about, where you can deploy an entire infrastructure on the fly. And this is going to lead to full-blown automation. You can take the event model, build a tool that spits out instructions, and then based off those instructions, and can build up infrastructure as code, as well as code itself, right? And last but not least, simplicity, right? And Adam brought that up earlier too. Quality or condition of being easy to understand or do. Developers can move from one team to another team, and if they're actually using that same kind of pattern and approach, the code base is familiar. And I'm going to show this. So if we go, so what I did is I did an experiment. So I had hotel management here. And this is something I wanted to do at my previous company because I wanted to demonstrate these patterns and what I was actually trying to achieve there. I wanted to get to a point where we could actually take, a solution from one domain and actually just copy it, rename the actual domain that you're in, the events, the commands, the entities, and you have a completely different solution. So I did an experiment, and I actually wanted to demo this in front of them before I left, and to show them what we're trying to do here. And so you can see hotel management. But I'm going to show you something. I wrote company management in 15 minutes. I basically copied over that exact hotel management over. I renamed it to company management. I changed reservation to registration because companies need to register or unregister. And I was actually able to just go through, create my register command handler, right? There it is. And there's your basic steps again. So when you look at this helps us bring to what Adam was talking about, that flattened cadence, right? You have all these different teams, they're responsible for products, and they need different solutions. And if you have to go build a new product, and you can take this existing code base, do some renaming, and go with the event modeling, have your command and your events, you can actually rebuild that fairly quickly. And that's where you would get that good rhythm when you want to deliver features. And that's what businesses are really, really looking out for. They want to have a predictable, smooth rhythm when they're delivering features. So that's one reason why I like the patterns and the practices here, right? The other, and one of the most important, is this is my last slide here, guys, is Conways Law. So the structure of a software, this is actually paraphrasing him. It says the structure of software will mirror the structure of the organization that built it. So using these patterns and practices helps move, and event modeling itself moves a company more towards small distributed teams, which then helps move towards modular and service architecture, as opposed to large collated teams. And I've seen this fail. at other companies where they actually do a whole organizational restructure. They introduce tribes, they introduce squads. But what ends up happening is they have this monolithic old legacy system. And the systems don't quite mirror the organizational structure. And that's where you get, and Greg used this earlier, impedance mismatch. You get that alternating current. You get the organizational structure. They're like, yeah, they're all excited. They got it all going or whatever. And then they have this code base and the systems that don't match. And it goes like that. And it's like an alternating current. So using these patterns in practice help us move towards that. It also helps us to have autonomous teams emit events, right? So if you have all these autonomous teams and they're all emitting events, guess what ends up happening? You have better flow efficiency when you're delivering features because you have less touch wait points, because you can actually go and look at, see if you're going with this new paradigm, every action and intent has an outcome, a statement of fact. Every single one of them. That means that every team, when they're following these patterns and practices, they're actually going to be emitting events, and the other team can see that, and then they can react to them. And they might not even have to get a hold of that team, which means less touch wait points, and it means flow efficiency, right? And also, all of you guys have phones. You guys all message each other, right? So if you guys are all messaging each other, and organizations are doing the same thing, why aren't your systems doing it? And that's where I'm leaving this presentation. Just think about that.